Good morning, students. Welcome back. Welcome back to the lecture series on signals and systems. This is a continuation lecture to what we have studied in the last lecture about the periodic signals. We have seen an important condition that the sum of two periodic signals. Okay, the condition for sum of two periodic signals to be periodic is the ratio of their periods should be a rational number. Okay, we have seen something like that. Okay, in today's class we shall start with that particular point and prove that and proceed further. Okay, okay, now we are going to show that a composite signal is periodic if the ratio of their fundamental periods is a rational number. That is, let us consider some x1 of t and x2 of t, which are individually periodic with the fundamental periods of capital T1 as well as capital T2. And now I consider the sum x of t, which is equal to x1 of t plus x2 of t, and I am intended to prove that that this x of t will be periodic if and only if the ratio of these two periods t1 by t2 is a rational number. Therefore, since given signals x1 of t and x2 of t are periodic, we can always write that x1 of t is equal to x1 of t plus t1. Since they are periodic with a period of capital T1, I just use that condition of periodicity where I write that it as x1 of t is equal to x1 of t plus t1. And similarly, since this is not only periodic, this is not only satisfied for this particular condition, but this is also satisfied for all multiples of t1. I can also write that x1 of t plus mt1 is also equal to x1 of t, where m is a positive integer. And this is also true in the case of x2 of t, where I can write it as x2 of t is equal to x of t plus t2. This can also be extended further and it can be written as x2 of t plus kt2, where k is a positive integer. Now, since we are intended to prove this x of t is equal to x1 of t plus x2 of t is a periodic signal, I consider that x of t is equal to x1 of t plus x2 of t. From these particular conditions, now I substitute and I just show that I just write it as we can still further write this as x1 of t plus mt1 plus x2 of t plus kt2. Since this is also equal to x1 of t and x2 of t, you can also still further write something like this. And for x of t to be periodic with a period of capital T, we require x of t should be equal to x of t plus t. Therefore, you can write from this particular equation, you can write that x of t is equal to x of t plus t. Then you can substitute it in that that particular equation, and we can write it as x1 of t plus t plus x2 of t plus t. So this can be further written as, since this is equal to this one, I just substitute in this particular relation where I can write it as x of t plus mt1 plus x2 of t plus kt2. So from the knowledge of this above expression or the equation, I can still write this further, and I could see that therefore m times t1 or k times t2 is simply equal to capital T. Therefore, I can now still further write it as t1 by t2 is equal to k by m. Okay, from this equation, you can write that ratio of t1 by t2 as k by m, and it represents, since k and m are positive integer values and it is a ratio of positive integer values, it represents a rational number. Therefore, now our condition was proved that in order to have your x of t is equal to x1 of t plus x2 of t and x of t to be a periodic signal, Now the ratio of these two periods, fundamental periods, should be a rational number. Similarly, the fundamental period of t, okay, the fundamental period capital T of x of t, fundamental period capital T of x of t should be the LCM of t1 and t2. That is the least common multiple. Since we know that t is equal to mt1 and kt2, I can just say that it is the least common multiple of t1 and t2. From this above discussion, now I can clearly say that the sum of two periodic signals is periodic only if the ratio of their respective periods is a rational number. And you can also see that the fundamental period is the LCM of their respective fundamental periods. Hope that it is understandable. And this same condition is also it also holds good for the discrete time signals. So now we shall proceed further in order to check these conditions for some signals, for some examples, and let us check whether they are periodic or not. And also if they are periodic, we'll also find out their fundamental periods. So let us consider a signal like x of t is equal to example 1. Okay, I consider x of t is equal to sine 12 pi t. In the previous lecture, we have already shown that sine omega naught t is a periodic signal when capital T is equal to 2 pi by omega naught. Therefore, considering here and comparing this particular x of t is equal to sine 12 pi t with sine omega naught t, I observe that omega naught here is equal to 12 pi, and therefore by substituting here in this particular equation of t is equal to 2 pi by omega naught, I get it as t is equal to 2 pi by 12 pi, which is equal to 1 by 6. Therefore, since here capital T is a ratio of two integers, x of t is periodic. X of t is periodic with a fundamental period of capital T is equal to 1 by 6 seconds. Okay, and similarly, we have also seen something related to a complex exponential signal. Okay, we shall consider another example on a complex exponential signal like x of t is equal to e power j4 pi t. Okay, and we have already proven that a complex exponential signal like e power j omega naught t will be periodic if capital T is equal to 2 pi by omega naught. By comparing this e power j4 pi by 4 pi t with e power j omega naught t, I consider that omega naught in this case is equal to 4 pi, and substituting this above relation to find out the fundamental period, I found it as 2 pi by 4 pi, which is equal to 1 by 2 seconds. Therefore, I can now say that e power j4 pi t is periodic with a fundamental period of t is equal to 1 by 2 seconds. Here clearly your capital T is a ratio of two integers, that is 1 and 2. Similarly, let us consider another problem on sum of two particular signals where x of t is represented as a sum of two signals which is equal to cos 2t plus sine root 3t. Okay, since we have already discussed about these kind of signals, now I consider x1 of t is equal to cos 2t and x2 of t is equal to sine root 3t. Okay, and now I'm trying to find out the fundamental period of this x1 of t, where by comparison with cos omega naught t, I find my omega 1 is equal to 2, and it implies that t1 in this case is equal to 2 pi by omega 1, which is equal to 2 pi by 2, that is simply equal to pi in this case. Therefore, the fundamental period of this particular signal is now equal to pi. And similarly, for x2 of t, the omega 2 is represented with root 3, and t1, since here omega value is equal to root 3, I have written it as omega 2 is equal to root 3, and t2 in this case is equal to 2 pi by omega 2, which is equal to 2 pi by root 3. Therefore, the fundamental period of this second signal is given by 2 pi by root 3. And since now we are intended to check whether x of t is periodic or not, we need to consider the ratio of their fundamental periods, the individual signals, and you could see here it is equal to pi by 2 pi by root 3, which comes out to be root 3 by 2 upon cancelling this pi, okay, in the numerator as well as the denominator. Therefore, the ratio of the two periods is given as root 3 by 2, and clearly here t1 by t2 is not a ratio of two integers, because we know that root 3 is an irrational number. Okay, therefore the signal x of t in this case, which is the sum of two signals, is non-periodic. This is how we try to check whether a given signal, a composite signal like x of t, which is a sum of two signals, is periodic or not. We need to just consider the ratio of their fundamental periods, and if it is a rational number, then it is periodic, and if it is an irrational number, then it is a non-periodic. Okay, so I'll try to end this lecture with one more example where the composite signal is a periodic signal. Okay, let us consider now x of t is another example, example number 4, where I consider the composite signal x of t is equal to the sum of two signals like sine 10 pi t plus cos 20 pi t. Okay, here clearly x1 of t is equal to sine 10 pi t, and its fundamental period t1 can be written as 2 pi by 10 pi. Since here the omega naught value is equal to 10 pi, therefore this is equal to 1 by 5 seconds. Similarly, for x2 of t, this comes out to be cos 20 pi t, and the fundamental period in this case t2 is equal to 2 pi by omega. Omega in this case is 20 pi, therefore 2 pi by 20 pi, which is equal to 1 by 10 seconds. So now, however, in order to check whether x of t is periodic or not, I need to consider the ratio of these fundamental periods t1 by t2, which is equal to 1 by 5 by 1 by 10, which is equal to 2 seconds here. Therefore, from this relation, you can clearly say that t1 is equal to 2t2. And we know that now t can be written as either t1 or 2t2. Okay, therefore, since our ratio of these two fundamental periods is given by a rational number, clearly our x of t is a periodic signal. And similarly, the fundamental period of this x of t is now can be taken as either t1 or 2 times of t2, which can be written as simply t1 is equal to 1 by 5. Therefore, your capital T, the fundamental period, also becomes the 1 by 5 seconds, which is a least common multiple of both these when compared with t1 and t2. Okay, this is how you will be verifying whether a given composite signal is periodic or not. That's all for this lecture. Thank you.